Hello, dear listeners. Welcome to Semaphore Uncut, a podcast for developers about building great products. In this new episode, Darko, the podcast host, welcomes software engineer and developer advocate Kelsey Hightower. Kelsey shares his experiences from challenging the status quo in large organizations to embracing the collaborative spirit of open source communities. Discover how Kelsey's contributions to Puppet and his role in the development of Kubernetes shaped the landscape of modern infrastructure. I hope you enjoy this new episode, and let's dive in.
Today with us, we have Kelsey Hightower. Kelsey, thank you so much for joining us.
Happy to be here.
Can you give us an introduction, to what you have been doing and how you ended up doing what you're doing right now?
When I think about my career, it's probably more similar to the majority of people who are practitioners in the technology space. I learned and introduced to tech right around the time where I think Linux was really starting to challenge the commercial software. I started with A+ certification, and I just started doing contracting work. And then there was a bit of my story where I spent 4 years afraid to go work in corporate America and decided just to open a local computer store. But the start of my tech career is really just entrepreneurial, acquiring skills. And then eventually I moved into the workforce, W-2. And my first job was a contractor at Google Data Center, early 2000s. At that point, it felt like tech was more like professional sports. Companies needed talent. They were willing to pay for that talent. They were willing to be competitive. And so I just really took on to, if I can just stay long enough to acquire new skills in that early phase. So it really wasn't about making an impact. And then I would say mid-career, I really got to more mature, slow down, make an impact, change the culture, really move the needle on how they were doing things versus learning how to do things. And I discovered the open source community. This idea that there was a whole subgroup of people, you could just jump online, ask them questions, and they would take the time to respond. And then you can also contribute to their projects to make them better. And so that whole world kind of defined my career, public speaking, open source contributions, and really pushing forward this idea of learning in public.
Semaphore has released the Flaky Test Dashboard to help you identify unreliable tests in your project. Identify which tests disrupt your pipeline and cost you the most, all in one place. Go to semaphoreCI.com/product/flaky-tests-dashboard to find out more.
Yeah, great. Thanks for sharing all those details. I just want to put timestamps on that. So that was from roughly 2000 for next 10 years, roughly. You were in the...
That's the 6-year period right there.
Okay.
Yeah, that period was fast. Every 3 to 6 months, I was doing the contracting jobs, from 99, graduating high school, getting A+ certified, Network Plus certified, and then jumping into consulting, doing the contractor work for about a year. And then you spend the next 2 or 3 years running your own computer store, consultancy stuff. And then you start doing these contract jobs, 3 to 6 months, 3 to 6 months, 3 to 6 months. And then I think around 2008, 2009, I get to a financial institution where I spent about 2.5 years. And around this checkpoint, this is when, for me, I had a collection of skills. I had an entrepreneurial mindset. I knew how to write software, and I knew how to do system administration, and I knew how to plug in cables in a data center if the time came. So you get to enterprise where everything moves a lot slower, right? You buy a mainframe, 2 years, it gets installed. Maybe you start using it in the 3rd year kind of deal. In those environments, you're almost taught just to learn the process and avoid any mistakes. And so at that job, I kind of learned that it's not really about knowing what to do or how to do it. You almost then have to convince the rest of the organization that we all should move forward in this direction. And that means training, learning new skills, challenging existing ideas and decisions. People don't realize you can collaborate however you want, but just simply naming your team DevOps doesn't mean you're actually getting results, nor does it guarantee results.
The obvious question is what happens next, but it seems that this was that, first big revelation for you, how actually things maybe should not be done and that there is a better way, connecting that with the movement.
In a setting like that, you can't just be right. you really have to do way more work to get everybody else on board and to be successful. So I kind of learned that. But also that's when I started making open source contributions, because I went from writing bash scripts to bringing in Puppet. And I remember the version. It was like 0.24.8. It wasn't even 1.0 yet. Red Hat just happened to be using Puppet for some of their automation for a Red Hat satellite server. So when you package your software in the Red Hat ecosystem, you package into RPMs, you store it in a YAML repository, but a lot of their automation was actually being done by Puppet. And they didn't really advertise it like that. And so you can imagine in a risk-averse enterprise where I want to bring in tools that are not even 1.0 from the open source world, that's not going to happen. But boy, since it was part of Red Hat, I was like, hey, it's enterprise, right? It's part of the Red Hat distribution. I'm not getting something else. And so the team was like, okay, fair enough. And it took years. You would have to wait till it becomes 1.0 or a big company is behind it to sell an enterprise contract. And I get it, why they would want that. But having Red Hat behind it checked a lot of those political boxes necessary to make progress. And those are the days when I just really started contributing. And so I remember the company is like, nah, we don't do open source. Like, we don't even know what that is. Like, you're not contributing that here. And so nights and weekends, I'm learning Python. I'm learning how to join this community, and I'm doing the contributions at home, waiting for the things to get merged so then they can get released by Red Hat so I can use it in the office. But that was when I kind of opened the door to the community. And I remember getting invited to give a talk at the very first Puppet Conf in 2012. The engineering team was like, hey, you should come by the Puppet office. So I went by there, and I knew them because once you start doing open source contributions, you're kind of a meta member of the engineering team. You follow the same processes, you work with the same people, and they gave me a job offer. So I'm going from like working as a practitioner to now, for the very first time in my career, to go work at the technology company powering the evolution.
What was the feeling? I think that the feeling was I imagine the feeling was absolutely amazing,
I felt like now I was moving into the people who create things, not just the people who use them and patch them, but now the people who are going to move the industry forward. And so joining the team, I was very proud, of course, to go from self-taught to now pushing the boundaries here. But it was natural because, again, I knew most of the engineers already because I was already contributing to the same code base. So coming to work, you're still working on the exact same code base before you join. So the ramp up period was straightforward. The decision making was very different because when you work for a technology company, you got to think about 10,000 customers. When you work in enterprise, you really only got to satisfy one real customer, which is that organization. So that part was different, that you have to go get consensus from the community. That means you got to go on. That's when I opened my first Twitter account just to say, hey guys, we're working on this. Please go upvote the issue if you think this thing is what we want to do, because we need to get consensus as a team and as a community before we make all these changes. But when you're on a team of all-star software developers, everyone can hold their own with code. Everyone has great ideas. And so you don't have a problem where you don't know who's going to step up and deliver. It's that there's too many good solutions and you have to bake it down to like, hey, which one are we going to pick? That is a really hard challenge because smart people get told no. And that can be demotivating for someone who has all of this skill and expertise to have to also fall in line.
How did, public speaking, apart from that, first, talk, how did it land in your life and career?
When you build something, your next step is to tell the world about it. So engineers eventually have to become good communicators one way or another. And so I think from the open source community, you have no choice but to be a communicator. So for me, being an engineer includes communication.
Now that you are mentioning years, 14 is the year where there is some initial work being done with Kubernetes, or there is like the first thing that came out?
So I left Puppet around 2012, 2013. Golang comes out, the Go programming language. And at the time, at Puppet, everything is written in Ruby. And remember, I come to Puppet because we were pushing things forward. And the team was like, hey, we can't use Go because it doesn't support AIX, right? It doesn't support some of our enterprise things. And I'm sitting here like, oh, so we're that company now. we're the people that are not going to be able to push things forward because we're trapped now in our own success of the current thing. And look, it was probably the right choice. But the real thing that made me know it was time to go was when Docker came out. Think about it. System administrators have been doing automation, but no one stopped to think about changing the actual abstraction. And then Docker comes along and says, what if you change the abstraction? Then configuration management starts having little use. Why would you go and configure a server when you just make the whole server read-only, move the app logic into the container, and then unify the differences between Ruby, Python, Node.js? Now these things are just the same. And you couldn't say containers at that time. Everyone thought it was a fad. They thought it was missing the enterprise use case. And I said, look, I think my time has come. And I go to this small company where I'm VP of engineering. You know, this is a pretty small bookseller. They do things where you can move your inventory to the cloud, sell at eBay. But a lot of things were written in Java, Python. People started doing some Node.js for the back end. And you can imagine a world, and I may be off by the numbers, but there are like 600 servers because of the inefficiencies of those runtimes, right? You know, they're using all this CPU, all this memory. And I'm like, I said, let's just try one service in Golang. And we did our first service and we just watched the memory and CPU just drop. I mean, if it took 300 servers before, now it's taking like 15.
Okay, I can relate to a lot of what you're speaking about because we were living through those times. Exactly. Global interpreter lock in Ruby, and I hated the chef exceptions with provisioning servers and all of that. We also we read the blog post from Heroku, so there was 2010 or so that they were using.
I remember that Rap Genius was having issues with performance and the router, and they wrote a really deep blog post that the math is not adding up. They're not getting what they're paying for.
And through that, we also through them discovered LXC. And when we started Semaphore, we said, wow, this LXC is, it's absolutely amazing, like zero overhead. And when actually Docker came about, it was very messy to run Docker inside of LXC. I'm sad that the industry took a bit longer to figure that out. And then eventually we switched to KVM, but the hardware became much more powerful and KVM also got polished a lot.
But, I think Docker got the UX correct, right? So the idea is that we want isolation for these bundles,
Absolutely.
Whether it's an app, a build environment. As long as things don't conflict with each other, you're probably fine. But if you think about now, it goes from LXC being replaced with Docker's own implementation to that whole layer is now pluggable with Run C. And so you can still have the same container image, but then run it under Firecracker or some other VM-like technology instead of just OS facilities. And I think that really spoke to that the UX was right.
Absolutely. I know that there is a piece that you are at CoreOS, right? What came at CoreOS, because that was the inception of that really, containerization.
So Docker's out for a while, and I'm writing Go now. I have an open source project in Go. I had some very small contributions to Golang. At this point, I believe I have a whole new set of skills, not just engineer, not just system administrator, not just someone who can talk in the public, but all of those things. What should I be doing next in my career? So I joined CoreOS, and I remember they had a very small team, 10, 14 people. The tagline was Google's infrastructure for everyone else. And we started building our own orchestration tool because you're right. Docker on a single server is nice. Docker across 50 servers is a whole different challenge. Like you don't even have IP management. So we built a tool called Fleet. CoreOS made a huge bet on systemd, where it would manage way more of the operating system. And systemd actually made the inner system much better. So we took etcd and we made it a configuration store for these unit files. So instead of copying systemd unit files to every server, you can copy unit files essentially to etcd, and etcd would push out these unit files and have systemd run apps. So if you think about it, you can just say Fleet deploy this. So we're using Docker images via systemd. The problem, though, is that these two things were on a technical collision course. Docker wants to be the init system in many ways. It starts first and it wants to try to manage all of its children. And that's a very hard problem on an operating system because you need to be hyper stable. Because if the parent crashes, then all the other ones get zombie. And Docker had a big problem with that. So trying to have Docker be started by etc or by systemd and then start running other containers, it was a nightmare when things went wrong. And so at this point, we decided to have a new runtime called Rocket. And Rocket is like, listen, systemd can do a lot of what Docker does. It can launch processes. It can create C groups and namespaces. It turned out you can do all of those things using systemd. So what Rocket was, it could pull images. So we had our own kind of image format. So we would pull down images, create a systemd unit file, and then let systemd do the heavy lifting. This is great. So Rocket was much, much smaller, didn't run as a daemon. And so now we were competing at the runtime level. All while Kubernetes is getting announced to the world as saying that none of these layers are important anymore. Kubernetes comes out and says, hey, the challenge you all have been facing, you've been trying to use the Docker API for a higher level problem, and it's an impedance mismatch. Apps are not a singular binary. No app is really that way. You need things like pods where you can have one or more containers. So you may need Nginx and your Ruby on Rails app because Nginx is going to deal with like multi-process management, terminating traffic, SSL. You can now orchestrate through our API. You can mount volumes, describe CPU requirements, and you can have multiple things in the same namespace, and you don't have to do all of these tricks.
Semaphore has released the Flaky Test Dashboard to help you identify unreliable tests in your project. Identify which tests disrupt your pipeline and cost you the most, all in one place. Go to semaphoreCI.com/product/flaky-tests-dashboard to find out more.
Maybe a quick comment on the CoreOS, their whole, branding and those colors and everything around, how it was like nicely, and clearly presented and all of them.
There was a guy named there, Rob. Eventually I became the product manager, and me and Rob used to work very closely. A lot of those designs were his.
It felt from the sidelines that Docker really didn't have the technical expertise or, kind of the domain knowledge to solve the problem that Google solved through Kubernetes. And now that you're retelling the story, it feels that, you guys at CoreOS actually started solving a lot of it around that. I just don't know if you were there in the real time, as it was happening.
Docker had the expertise. They abandoned orchestration. They abandoned all of these things that we know you have to do in a distributed system, and they doubled down on this developer productivity, and it works. And it sets the stage where we're getting people on board that there should be containers for everything. We're getting the ecosystem. We're pushing so hard that we push against the limitations of the approach. So they had the expertise, and once that momentum hit, if you're Docker, if you're CoreOS, you're like, hey, we're just going to build around Docker, right? And we're just going to add the layer we think complements Docker. And at that time, if you're Docker, this is fine. Let CoreOS do orchestration. Let Red Hat do operating system. We're going to capitalize on container images and content and more developer-focused tools, and it's going to be a nice, happy party, which is normal because like programming languages tend not to ship with their own deployment tools. Most programming languages don't even have their own package management tools. So this is already kind of the healthy balance. But remember, at this time, this is VC funding. Valuations are billions. There's unicorns. And so Docker is saying, hey, we see what CoreOS is doing. We see what Mesosphere is doing. Remember, Mesosphere is thinking about bringing in container images. Heroku adds support for Docker images. Cloud Foundry adds support for Docker images. So you already had the major orchestrators bringing in Docker. So there was no reason really
to compete
to have yet. Yeah, it just didn't make sense.
Clear.
But when what Google did, Google had the expertise, but even lost in that domain to a startup.
Yeah, UX was wrong.
And so Yeah, for Google, the UX was definitely wrong. Now there's so many people globally that now understand the problem very well. Everyone's running Docker. And so you look at that and it's like, why would you even jump in? So Google looks at this. They know one thing. They write the Borg paper, they write the Mesos paper, and they realize that you got to have a much better dialect to describe this problem space. And that pod concept where you can group volumes, config, networking, storage, CPU requirements, this is the only thing you can get from experience. So they got that part. They nailed it.
Yeah, wanted.
But we didn't have volumes in the beginning. We didn't have configs. That came from Red Hat. OpenShift brought in those design decisions of you need that way to distribute configuration. You need to mount NFS because the real world has NFS and POSIX file system where Google didn't. So it really took the whole community. And again, it also took Docker continue to add new features. Like Docker said, use a bridge. Kubernetes inherits the bridge and just exposes it through, the normal means. So if we were being friendlier to each other, there was a massive collaboration happening. CoreOS figured out that you can have a read-only operating system and get rid of the traditional OS mechanics. GKE, the commercial Kubernetes offering from Google, has a read-only operating system that looks a lot like CoreOS. If you look at Docker in many ways was evolved where we decoupled the Docker runtime, containerd that pulls and manages images, and then run C, which allows you to have WASM support, Firecracker support, or LXC, or whatever container technology you care about. And so if you really think about it, we had all three of these people doing what they do best, but there were three different companies, and Kubernetes kind of squashed those layers down to one thing. And so, of course, the talk of the town is Kubernetes, 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 because that's where your journey now starts.
One of the reasons that why to me and to my coworkers felt that, maybe Docker didn't have expertise was that point when we saw Kubernetes around the pod and all of that. So many things just felt so right that it felt these people really know what they are doing. I'm just connecting to your comment that you can only get that through the experience. You cannot sit in front of the whiteboard and come up with all of that.
And remember though, that move is still luck, because you got to remember to implement pods, Docker already had this facility of the somewhat the sandbox, but this idea that you can start a container and join another container to it. They pushed the boundaries on matching the way people think about production workloads versus what the runtime is capable of. I give credit to the extensibility of Kubernetes. Docker had a very rigid networking contract. You can only do the things that Docker did. That's it. To me, that was the thing that said Kubernetes and Docker for orchestration are not the same. OpenStack and Kubernetes are not the same. You don't have this level of integration and first-class orchestration capabilities that Kubernetes had. So the CRD, mission controllers, and the ability to extend the system by using the same facilities that the system itself used was a game changer.
I contributed, deployments and a lot of those features, through just, the Kubernetes team and that, ingenious little group of people, which to me is now clear that it was actually a great collaboration across multiple giants from the industry, actually, to make that happen.
Independent folks globally. I mean, so many people were scratching their own itch. And the thing I think people overlook here is Google's humbleness to not say we know everything. Google said, let's just reuse etcd. Let's use Docker. Let's use the things that are already there and add our expertise on top. That to me was like the big game changer, because they could have came in and said, oh, let's get rid of Docker and give you a better runtime. They didn't do that. They layered on top and did the hard work over time to make all the layers better.
Who would you contribute that wisdom of how it should roll out with and play with the others, and who are the folks that had that understanding of how technology really?
I don't know if anyone had the solo understanding. There's so many people. So I think at the same time, everyone was spreading out and saying, this is the way, this is the way. And then when we fell short, they would step up and close the gap. Even the people who thought they were competing with Kubernetes gave us so many ideas that we didn't have arrogance to ignore.
Absolutely amazing. Can you give us a glimpse of, what are the things that you're working on?
How about this? I'll promise a part 2. I thought I was retiring in July, and we all talk about what it's like to work, but I don't think a lot of us talk about what happens afterwards. So maybe we cover that in a part 2.
Okay. Thank you so much for doing that for us.
What a great conversation. We hope you enjoyed it and learned something new. Make sure to subscribe to Semaphore Uncut on your podcast player of choice so that you don't miss our new episodes. And stay tuned.